No, you just got
All right, ladies and gentlemen, if I have your attention, please. See here. Derek, can you get your thing?
What?
Antonio, can you get your thing? Charles, I hear. Derek, can you get your thing?
Go on the board.
All right. Reminder, if you have homework, you need to show me. At this point, you can show me after class, or you can show me at this point after school. And there were a bunch of you who needed to show me assignments 1, 2, and 3 because you don't bring your stuff every day, which is fine. But you got to show it to me today, else I'm putting zeros in. No matter if you were absent, whatever, it's going in. All right? I would just say after class is over and just do it. All right. So today, we start a new unit. What I would like you to do. Go ahead and let's read this real quick. Have your attention up on the board. In this next section, each pair of you will be given one new vocabulary word.
Oh my God, with a pair?
You have 3 minutes to find the definition and write it on a small slate to present to the group. You can use the textbook, which there is now a geometry textbook under every other desk. All right? You can use your phone, previous knowledge with a computer at the front and back of class. After I assign you your word, I need you to please write the definition symbolically and as a conditional statement. So, what you need to do in the next minute, you need to A, sign your next to your partner. B, get one slate. C, get a marker and a dry erase marker from next to Camden. You have 1 minute. Go.
Yeah,
Yeah, fine. No, do it. Not right now.
Oh, sorry.
No, I want under the desk.
Alright, we need a big plate.
No.
I don't feel like getting the leg of time. That's your foot.
It's not. You just show me not during class.
Oh.
Come on, Edward. Oh, big plates are fine. You can get a little plate too. Doesn't matter. I'm going to give you this stuff to get your marker. Here. Okay.
Okay.
Good. Let's be in our seats in 30 seconds.
You killed her.
Yeah.
I got that. Well, Matt's up to the actual stand.
Good. 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 A little plate is fine. A little bit is fine. That's fine. All of them are in the best.
Yeah, we're ready.
Yeah, you can see yourself right there, right?
Yeah.
So as long as you're on the thing, that's all I care about. All right, let's be in our seats in 10. All right. Looks great. What? There, who's your partner?
No one. You're my partner.
Dominique, come over here with Ken. Dominique, who are you with? Noah? You do those people, yeah. I only have a certain amount of vocabulary, so. Dominique, come work with Ken. All right, here's what I'm going to do. I'm just going to go around the room. I'm going to give you your word. Go ahead and put your word on your slate. Then, after I assign everybody words, I'm going to go back to the very first one. I'm going to give you an example of how I want you to write your definition. Then I'm going to put a timer up. You'll present your definition, and we'll move on to that. All right. Eventually, you're going to write all these in your notebook. Yeah. All right. So, just going around the room. Subtraction property of equality. Multiplication property of equality. Division property of equality. So you write that down. You have it. So I can move on. Tyler, inverse property of addition. Dylan, inverse property of multiplication. Derek, identity property of addition. Ari, identity, property, multiplication. Bradley, reflexive property. Amy, symmetric property. Tacho, transitive property. Sabrina, substitution. Danny, commutative property of addition. Dakota, associative property of addition. And there's a group of three. Kayla, you guys also do the distributive property. Yes. Now what I want you to do. You guys have a distributive property, and you use the commutative property of addition. Okay, so real quick, even if you've already started looking your thing up, what I need you to do is I need you to look up here at the addition property of equality. You'll have time to take this down in your notebook later. So, here's what the addition property of equality states. It states that if x equals y, then x plus z equals y plus z. That is what the addition property of equality states. What I need you to do in the next 3 minutes is figure out how to symbolically, in a conditional statement, write the definition for the word or phrase that I gave you. I am setting your timer. You can use computers, phones, whatever you need. There are books underneath desks.
They're dividing both sides.
How can we make 4 sentences out of 3 words?
Anyway,
Yeah, I'll do that. Save it for him when you keep and I got it. Oh, that's what we talked about. It's hard, right?
You're going to have to go there. It also might be in the intermediate book underneath you, the intermediate algebra book. Find it? Find it? You guys find it? It might be in the other book under her name.
I don't give a fuck. It's A! He's there.
How do you spell equation?
You have a little more than a minute and a half. Do one try.
Will you tell us what we get it?
And by a time. I don't know. You don't have time. What are you doing? Multiplication property of addition? Yeah. A plus B and A times B plus B. That's right.
I can go. Get it hard, you do.
Oh.
You're the first person who's actually ever done it.
I don't have a problem. No, that thing is the breakfast. No, it looks like it's also TV. My was on the ranch,
It's been way more than 3 minutes. I'm not sure.
I literally have an alarm going. You have 20 seconds.
Oh.
We're actually we're back.
I love this break.
After you.
Oh,
Okay.
I think my days will be Monday and Wednesday.
I guarantee there are things.
I know, I went in there and I was getting access to the chat and I was
Okay, you're done.
That was terrible.
This is fun. All right. So here's what we're going to do. We're just going to go around the room. If you're not quite finished, I would ask that you silently finish. You are responsible to know all these words. So what I would do is I would open up my notebook as I'm doing presenting. I would write down addition, property of equality. I'd write down the definition I gave you. And then when Camden and Q present their subtraction property of equality, I will write up there what you need to know, and you should copy it down. Yeah. Yeah, I want to get that. If this, then that. All right, ladies and gentlemen, we're going to start in 5 seconds. All right. What does the subtraction property of equality state? And
If A equals B,
if A equals B,
then A minus C
then A minus C
equals B minus C.
equals B minus C. That's exactly right. The subtraction property of equality states that if A equals B, then A minus C equals B minus C. I'll help you if you can't get it, man. Or if you have a definition, I'll put it in the text when I write it. Because I won't mind it. So, once again, the subtraction property of equality states that if A equals B, then A minus C equals B minus C. The previous definition will hang out while we do the next one. The multiplication property of equality. Edward and TJ, are you guys?
No, we're division.
Who's multiplication? Kaylee, Dominique, what do you got? If A equals B, then A times C, then A times C equals B times C. That's exactly right. If A equals B, then A times C equals B times C.
We did this wrong.
So what you got? And I'll help you out, okay? Give me 1 other second just to kind of think from here.
Oh.
I tend to move quickly sometimes in notes. All right, Edward. So, looking at what you guys got, what's going on?
We wrote the definition.
Okay, what's the definition?
The division property of equality states that dividing both sides of an equation by a non-zero doesn't affect the equation.
Okay, so how would you write that in an if-then form based on the 3 examples you've seen?
It's basically the same way, just with division.
Okay, so go ahead and read it to me.
Okay, if A equals B,
If A equals B,
then then A divide
divide, and one more.
equals
Then A divided by
B
C
or C
equals.
B divided by C.
And what was the one stipulation that you found?
That's the difference.
What's the one, like in yours, there's something special, what is it?
Oh, there's a non-zero.
Yeah, so and this is if and only if C doesn't equal 0. Okay? I just put it in there. No, I just wanted to break it apart into stipulations. Because write that as a biconditional, you would say that A divided by C equals B divided by C if and only if C doesn't equal 0. But you wouldn't have that first part, A equals B. All right. Anyone need more time with the equality property? Sabrina, okay.
What?
I just asked you to need more time to copy. Sabrina raised her hand. So I said, okay.
No, I looked at some boards.
Ari, are you just not happy with your definition? I've seen you look it up like 3 times. All right. Inverse property of addition. Mr. Parrish, was that you?
Yeah.
All right. What is the inverse property of addition?
Okay, so if A minus A is 0, then B minus B equals 0.
If A minus A equals 0, this is what they put, then B minus B equals 0. Yes. That is the inverse property of addition. That's good. Having that in if-then form probably isn't necessary. The inverse property of addition, you probably just don't see it as A minus A equals A minus A. All right, let's go with that. All right, how about the inverse property of multiplication? Eric?
We don't have that for the other.
All right, what do you have?
It's every non-zero number can be multiplied by 1 over A is 1
That's for the inverse. So what they said is that any number A multiplied by 1 over A equals 1. So any number A where A is non-zero, so if A is non-zero, A times 1 over A equals 1. Right, we use that all the time. Multiply fractions by the reciprocal to get rid of them. Inverse property of multiplication. Identity property of addition. Austin, what do you got?
If A plus 0 equals A, and B plus 0 equals B.
Yeah, so we're going to know this as A plus 0 equals A. Identity property of addition. A plus 0 equals A. We just didn't need that one in the if-then form. That's all there. Ari, are you ready?
Yeah, yes.
Why are you over
Identity property of multiplication. Go ahead, Deborah. Yeah, so this is A times 1 equals A. A times 1 equals A. So all we're saying here, these are just foundationally, these are just kind of all the mathematics that you have been doing for a long time. And one of the big things we do in geometry is we prove things, we say the proofs. And so you have to know what is happening in the background, what is going on. Right? This is what we're trying to address here. Can I move on from identity property multiplication? Bradley, do you have a question that was on the topic? Okay, move on. All right. If I had to highlight any, these next 3 are the most important ones for geometry. All right, these next 3 are the most important ones for geometry. Reflexive. Aaron, what is the reflexive property?
If A times
That's a distributive property.
so minor relation offset every other.
So the reflexive property, X equals X. Okay. That's the reflexive property. That's what you wrote. That's what you wrote.
Why is that a question?
Because, so what we're going to eventually get into is we're going to prove triangle congruence. Okay? So imagine you had a square with a diagonal going down through it. And we're trying to prove side, side, side. Well, we know that these two sides are congruent to these two sides by the definition of a square. But how do we know that that diagonal is congruent to itself? So we can prove side, side, side by the reflexive property. All right, what are you doing? Your math. All right, how about the symmetric property? Amy? Yeah, if A equals B, if A equals B, then B equals A. It is. It is very self-expecting. I never, knowing these is not difficult. Knowing when to apply them in a proof is difficult. And these are index cards worth. In case you're wondering, they will go on the word wall probably during lunch.
So all those words right there on the word wall,
That would be my suggestion. I'm not going to check them or collect them. That's just my suggestion to help you remember.
okay.
Orange? That's what we're doing today. Yep. I have them for you if you weren't here that day. Deborah? Because Bruce was up. Well, we're gonna walk through a couple, and you'll see. And if Deborah, if they're not for you, then that's awesome. So let's just find out once we get the proof to see how it goes. And transitive property. Anthony, what is a transitive property? Okay, hold on. Well, if A equals B, so A equals B, and B equals C, then A equals C. So if A equals B and B equals C, then A equals C. So that would be like saying if 2 equals 2 and 2 equals 2, then 2 equals 2.
No.
Like I said, if I had to tell you algebraically, these are very straightforward. Geometrically, they get a little more confusing. I would star these three, as these are three that you're always going to be using when we do proofs. Yes. Yeah. Just so you know, there's not a summative over this chapter. There's 2 performance assessments, and there are 5 quizzes.
What the hell? 5?
You've taken 5 for every chapter.
Oh, all right.
All right. Moving on. So next we have substitution, which I'm not sure why I'm not speaking about. Okay. Sabrina? If A equals B. That's perfect. If A equals B. Whoa. If A equals B, then B can be substituted if A equals B, then B can be substituted for A in any equation. Right? So if A equals B, then B can be substituted by A in any equation. And B can be substituted, okay, that's a 4, that sounds better. That's what the green says. If A equals B, then B can be substituted for A in any equation. You guys do this all the time. Evaluate this expression where x equals 3 and y equals 4. 2x squared plus 3y equals 9. And you would solve that expression. You guys do it all the time. All right, commutative property of addition. Who has the commutative property of addition? You guys. Who is talking this time? Kayla, what is the commutative property of addition? Term. All right, so what Kayla just said, slightly quietly, she should put that away. A property of real numbers that states that the sum of 2 terms is unaffected by the order in which the terms are added. symbolically, here's how we represent that. A plus B plus C equals C plus B plus A. Once again, this is something you guys do all the time. We always shift stuff around. Yeah. Yeah. Any problem?
Taking a step. Yeah. Not like,
Back.
got it.
Commutative property of addition. Associative property of addition. Dakota, what do you got? What the associative property of addition states, it has grouping symbols in it. So it says A plus B plus C equals B plus C plus A. So it doesn't matter what order we arrange as long as everything's being added. Right? We could add 2 plus 3 first, and then add 3 to it, so something like this. So 2 plus 3 plus 4. Or we could do 3 plus 2 plus 4. And we would get, here we get 9, and here we would get 9. It doesn't matter how we group things for addition, or multiplication sometimes. All right, and our last property. This is the one that most students do very well with on the name. Taylor, you guys do distributive property? Danny, what is the distributive property? It was on the internet. It must be the truth. ADD, EMB, added. All right. Here's what the distributive property states symbolically. It states that A times the quantity B plus C equals A times B plus A times C. That is the distributive property. And once again, I think whatever they teach you guys down in the elementary level about distributive property, every student remembers distributive property. It is never an issue. All right, what I need you to do now, I need you to have 1 minute. Please take my markers, put them back in upside down in the black box. Put these slates away, erase them, start a track, move your desk back, and we will reconvene in a minute.
Quickly?
Yeah, 1 out of 5.
Edvard, did you pass it?
You're right. Hey, Eric. Not locked out.
That's bad.
I was redoing it.
You can only miss
Well,
six.
I'll go like big 10 and take you.
That's it.
Yeah, tell you how many fails you have. Yeah, it tells you correct and fail.
Edvard, you can miss a six. How many more you have?
Ladies and gentlemen, my timer is going off. You should be back in your desk. Please, thank you. Your notebook should be out. I don't know, Taylor, why your phone continues to be out today.
Take it away, take it away.
Your notebook should be out. You should have copied down. Unit 5, Lesson 5. Introduction to 2-column proofs. That's what it says behind the screen. You can't see it. It says proofs. Yeah. Yes, you can hear me every time. Which is, if you go online and look up the video, so if you're ever absent from class, you can go online to Edmodo, and you can get the video, you can watch exactly what happened, follow along, and you can, take notes. It's okay. I'm loud enough that it picks up.
Me too.
All right, yeah.
What's the keyword?
Proof.
Proof. PROOF.
All right. My assumption is if you went home and talked to your parents, as long as they got through geometry, or at least took geometry, they've done proofs. Everybody's done proofs. People don't like proofs. The reason you don't like proofs, well, certain people like proofs. People who are very detail-oriented and meticulous enjoy proofs because they are detail-oriented. So, here's what we're going to do. We're just going to hop right in. All right. Ladies and gentlemen, you are talking too much today. The two of you are going to be split up again. Just let you know. It's going to happen. All right. Here's how something will be set up. We're learning two-column proof. When you have a two-column proof, amazingly enough, there are two columns. All right? This is why it's called a two-column proof. And you will see up here that we have statement over here on the left-hand side. And we have reason. We've been using this word justification. Justification is a type of reasoning. All right? You are not going to see justification written here normally. It is always going to say statement and reason. I need you to know why we worked on justification for so many weeks with you guys, to think about what you're going through. And so that way, hopefully, we're going to see this pays off this year. Getting the proof, you guys will understand how you work through and think through your steps. All right, so just getting through the basics real quick. Here's how you normally are going to approach a proof. So here we can see we were given that 3x equals 9. And what we want to do is we want to prove that x equals 3. Once again, you guys are really comfortable with algebra for the most part, simple algebra. So we're starting here. So I think most of you can look at this and be like, duh. Obviously, I don't need you to do duh. I need you to, we're going to prove it. That's what we're going to do. So our first, Bradley, stop. Our first statement is going to be 3x equals 9. And the reason is going to be given. Right? We were given that 3x equals 9. Because see right here where it's given, we have to have a reason for writing every statement, Deborah. The reason for writing that statement is that it was given. It was given to us as the place to start. Every step. Yeah. We just started, right? You can't. We bring one thing.
What is this gonna do with like job world?
Life and job world?
Yeah.
I mean, besides demonstrating critical thinking skills, working through problems that are more difficult than what you can do on a day-to-day basis, thinking outside the box, being detail-oriented and organized. Those are just 5 that I can call myself life.
Wow. Okay.
All right. All right. So.
Yeah.
All right. So, if you were solving, I have a pretty nice job in job security for math. It's like what do you math? No matter how much you guys say.
I just don't like that.
You guys show up here every day with me.
I like first grade math.
All right. So let's take a look at this. What would be, if we were solving this, what would be step number 1? Edward?
Isolate the x.
Isolate the x. Good. How would we isolate x in this case? Yes. We would. So here's what we would do. We would say 3x divided by 3 equals 9 divided by 3. Looking back at your vocabulary, what property was that? No.
Quotient property.
Sam? Division property of equality.
Oh, the name was allowed. We have to write that out.
Division property. Division property of equality.
I think it's the property of.
Just get used to writing, but I think that's why most people hate proof, because all the writing.
Nobody likes it.
Okay, everybody. If I can have your attention, please. All right. So here we go. So what is 3 divided by 3? 1. So we get 1x equals 3. And so this is we just simplify.
You can put it.
All right. And the final step. Can anyone take a guess at what the final step is going to be? Bradley? Isolate the x. Good. And so what property do we need to use to get rid of, what does 1x equal? It equals x. By which property? I can tell you right now, I have my property sitting in front of me. I am not, like, pulling it off my head. I have them sitting in front of me. I would recommend you doing the same.
Are we supposed to just know these, like, memorize them?
Eventually, we're going to work on it in a couple days.
Okay, good.
It is, we get x equals 3 because of the identity property. Identity property of, oops, I've got property. Identity property of multiplication. Oh, I got it. There you go. Yeah. Because 3 times 3 does equal 9. That's fine. But how do you know that x equals 3? So you could prove that using substitution in the transitive property. That'd be good. Eric? Because we're going to prove like triangle congruence, quadrilateral congruence. We're going to prove vertical angles. We're going to prove adjacent angles and complementary angles. Alright, so let's try another one. Alright.
Are you doing the keyboard this time?
Yeah, I'll type the reasons this time. Alright, given x minus 4 equals 10,
So we write that.
prove x equals 14.
You somebody really get like really intense.
Oh.
Run like level.
I don't know how far we're going to go, but I can tell you generally
Level 1.
there's always like a solid like 14 or 15 step proof in geometry. And we'll do it at some point. It'll probably be it'll be your performance. So it'll be something that you'll have your notes available to you and you have to work through and you'll like think so. Yeah, that's what you're just doing right now, like your project. Basic algebra? Yes.
Geometry.
Ladies and gentlemen, kind of please. All right. So, taking a look at this. What is the first thing I'm going to write under the statement column, this parish? Yeah, we're going to begin. We're going to x minus 4 equals 10. You know what? Let me go. X minus 4 equals 10, and that was given. Right. So x minus 4 equals 10, and that was given. Okay. So go ahead and think about it for a moment. Like Edward said last time, we're just trying to isolate x. what would I do to isolate x? First, I just want the statement. Taylor, what would the statement be? Yeah, we get x minus 4 plus 4 equals you didn't step in. All right. Which property was that, Edward?
It was, the addition property of quality?
Addition property of quality, good. So we get the addition property of quality. What was the question again? Addition property of. Oh, we got it. Okay. Now, not all the time. Which is, I mean, Derek, we're just trying to right now, our goal for today is to introduce you guys to two column proofs. That's our goal for today. Yeah, there's two. There's two proofs.
Oh.
I should have copied it.
How many columns proofs are there?
There's two. There are two column proofs, paragraph proofs, flow proofs. You can look it up in the book. All right. What dot, please? Deborah. All right. So, what is negative 4 plus 4?
0.
0. So we get x plus 0 equals 14. We got that by... Okay. Now, which property is it when you have x plus 0? Which property is it, Aaron? Identity property of addition. So, we can say that x equals 14 because of the identity property of addition. I cannot hear you.
Oh, wow.
Right? You guys are doing really well though so far. We've gotten farther than the other classes we got. Good. You're doing really well.
Yeah, let's stop. Take it off.
I'd rather give you the last
Good job,
one.
guys.
It'll make your homework easier. That's a really good question. So, ladies and gentlemen, if I can have your attention real quick. Edward asked us, all we know is this proof. We know that we're done if we can get to the last statement, and our last statement is what we were trying to prove. We were trying to prove that x equals 14. We proved that x equals 14. It took us 1, 2, it took us 4 steps. Yeah. All right. All right. Oh,
bueno.
Yeah, we're done.
No good.
all right.
Did you give us time to show you the homework?
All right, there we did it. That was easy. Done.
Okay.
No, that's outside of class time. All right, go ahead and get this one copied down. Given 2x plus 3 equals 9, just leave space. Yeah.
Each box has a memory article.
He's giving us, okay.
Keep on with that.
Yeah.
Look at that.
I think
That's bueno.
That's what.
until it's,
Good. No, it's white people.
I'll pick up when we get to there.
Yeah, yeah, you're white.
Good. Your notes look good. Thank you, people. All right. So, once again, we're going to start here with our first statement. We're going to say that 2x plus 3 equals 9. And that was given.
Is it always going to be given?
The first thing you do,
Yeah.
usually, we shouldn't say always, right?
Yes.
We box ourselves into a hole if we say always. All right. Step number 2. What do you want to do next? Deborah, what would you like to do?
I never experienced that though, because you have to do like all this like, this, like this open flow.
Oh, I got it.
Deborah, we need to get x by itself, right? There are 2 things happening on the left-hand side of the equation. Okay, so how do you remove a plus 3? Using what property? Which property, Caleb? Yeah, we want to use the subtraction property of the following. The subtraction property of the following. Usually. Subtraction, oh, not the subtraction property of subtraction. That's the equality. Liquidity.
Maybe.
No way.
Is it what?
All right. So now I get 2x plus 0 equals 6 by simplifying. What is 9 minus 3? Yeah. And once again, this is just to introduce you to proofs, because you're better at algebra than you are at geometry. All right, when we add 0 to something, which property is that? TJ, which property is it?
What?
Right here. How do we get this? So 2x equals 6. Using which property?
No.
Nope. Identity property of addition. Identity property of addition. Ooh, I like this box. Next, I get 2x divided by 2 equals 6 divided by 2. That is the division property of the volume. Actually, there's a box right here. Enjoy your evening. I have your homework printed out for you. Travel on your way out. We'll pick up here tomorrow.
That's what you're doing there.
No, it's good.
Wait, so we don't have to hold it later?
Why do you throw everything out?
My other homework.
You don't, you stop failing.
So this is my other homework.
Oh, yeah, I'll check it right now.
I'm gonna bring it to you.
No, it's okay, right now. Yeah, I'm leaving right after school.
I forgot 2 pages at home. My mom's bringing it to me.
Give homework 1, 2, and 3. I said, what's that? Gonna repeat it?
I only have 3.
Anybody else need a homework?
So you might
You're all happy.
Okay.
I do. I'm gonna have 10 more days. So you told me to.
All right. Derek, what do you have?
Like, no. I'm gonna do.
That's homework number 1.
I looked at it.
And you have vocabulary? Okay, what do you got, Deborah?